So for intensity, meaning how bright are these spots? And do they stay same brightness as you move away from the center? Yeah, no, they don't. The middle one would be the brightest. In fact, I think 85% of the intensity is there. And then the rest get much less. Okay. So how do we get intensity? If you remember, for intensity, you have to go back to electric fields, and then you square that electric field, right? So here, what we have is what's causing this intensity. We have all kinds. We have electric field here, 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 right? And each of them is sending light rays in all directions. Now, the light that goes in, you got a total electric field E, and if I divide it into n slits, the electric field will be E over n for each of them. The amplitude for the electric field for each of these dots is E over n compared to the total electric field. Okay. So let me call the first spot here is E0, E1, 2, 3, 4, 5, 6, 7, 8, 9, all the way to n. Okay. So E1, E0, sorry, will be E over n, total electric field divided by n times. I'm dividing it into n. And n can go to infinity, and then it becomes continuous. But n will go away anyways, it will cancel. E over n times the cosine of kr minus omega times t, okay? Let me just draw something here so we know what's going on. So here is one, E0, this one right below. Troubles here. Okay. And then there is the one here, and the one here, and the one here, and so on, all the way to here. This one here, I'm going to call it En. This one. So, distance from here to here is A, right? Is A. And this angle here is theta. So what's the path difference between these two? What's the path difference between that one and this one? So for the En, I would have this. E over n times the cosine of k r for n, that's the distance of travel, minus omega times t. But I know that r sub n minus r, what's the path difference between the blue one and the yellow one? A sine theta, good. It is A times the sine of theta, right? A times the sine of theta. And so r sub n will equal to r plus A times the sine of theta. That means k times r sub n will equal to k plus k A sine of theta. But what's k? Ki, thank you. What is k? 2 pi over lambda. Okay. So I have here k r n equal to k r plus 2 pi over lambda times n. Times A times the sine of theta. Okay? Yeah.
Why'd you only change 1k?
It's still correct on purpose. Yeah. These two, I'm going to just plug them in as is, and this one is the one that I care about. You agree it's still correct, right? So this thing here, this whole thing, I'm going to name it beta. Okay. So in other words, this K R N is equal to K R plus beta. That's for the nth one. For the nth one. Now let me ask you the following. Let's say I go. How far? What's this distance from the first, from the 0th one and to the first one? What's the distance between them? If I divide the slit into n parts. A over n. Good. How about the second one? Between the first, the 0th one and the second one? Would be a over n times 2. So 2a over n. Yes? Because this, each of them is, each distance is a over n. So 2a over n, 3a over n, and so on. So the ith one, let's say I go here, just to generalize, let's say this one is the ith one, it would be I times a over n, right? So, in other words, here's what I'm trying to say. K R I, the ith one, will equal to K R plus, what would change here? Instead of a, it will be what? A over n times I, right? Yeah. So you have I over n times this whole thing.
So it'll be the I over n.
So it'll be I over n times beta. I over n times beta. Let's just double check. For the 0th one, the first one, you will just get KR equals to KR, because I is 0. For the 0th one, I is 0, so that goes here. For the nth one, you would plug in n here, right? N over n is 1, and so it checks out, right? Okay, so let me write down some electric fields. Okay. So E0 will equal to E over n times the cosine of KR minus omega t. That's it, plus 0, okay? If you like. There is nothing there, it's just 0. For E, let me write E1, it's E over n cosine of KR minus omega t plus 1 over n times beta, okay? 1 over n times beta. That's what I have to plug in, I over n. For E2, it's going to be E over n cosine of K R minus omega times t plus 2 over n times beta, okay? And you can keep doing this all the way to En, which is E over n cosine K R minus omega t plus what?
Beta.
Plus beta, yeah. It's n over n beta, so plus beta. Okay, sounds good. Now we can choose our 0 wherever we like, so we can choose KR minus omega t to be 0. We can choose that to be 0. Or we don't have to. But I want to just show you something. For then the total electric field at this point, will be the electric field from this one, plus this one, plus this one, plus this one, plus this one, and so on, right? I need to add all of those electric fields. Yeah, so it's going to be a summation, and we're going to do it in the worksheet, you're going to do it differently from this. Today we're going to do it in the following way. We're going to think of, E0, let's imagine here's E0, right? What's the magnitude or what's the amplitude of E0?
E over n.
E over n, good. What's the amplitude of E1?
Same.
Same. All of them are worth E over n, right? All of them have the same size, but they have different angles. notice the angle, every time I go from one to the next, the angle increases by a factor of beta over n. Increases by an increment of beta over n. So if this is E1, here is E2. I'm sorry, E0, E1, E2, E3, E4, and let's say this one is En, all the way there. I only drew 6 of them. Okay? So that's what I get. And the total electric field is going to be the sum of all of these. What's the sum? If you have vectors that look like this, what's their sum? It's going to be from the tail of this one to the tip of that one. That would be the sum, right? So let me draw this on x-axis. Like this. I'm going to draw a tangent here. What would this angle be, the tangent here? The first one made 0 degrees with the x-axis. The first one is going to be I over n times beta. The very last one will make what angle here? Beta. Yes. The very last one will make an angle beta. Okay. Does that make sense? Or all right, good. If it does, then that's great. Then draw one more. I want to draw perpendicular to this one. If this is beta, this will be 90 minus beta, and so this will be beta. Extend this one. If this is beta, then this is going to be beta also, right? Yeah? I'm sorry. If this is beta, then this is going to be beta. If this is beta, the top one should be beta. Yes, but what did I? Oh yeah, this is not it. If this is beta, this is beta. Yeah, this is perpendicular. Okay. So is that clear? If this is beta, this is 90 minus beta, so this is beta. And this are vertical angles, so that's also beta. And if this is beta, then this line and this line are parallel, so this is alternate interior, so this is also beta. That's also beta. Okay. Now I know I'm right, because that angle should be beta. I was lost for a second. Okay, so first of all, let's think about this arc length. How long is this arc length? How long is that arc length? How long is each segment? E over n. And I have n of them, so what's the total? E. Yeah, so the arc length is just E. Each little arrow is E over n. So I have n of them, so the total arc length is E. But the arc length this is part of a circle, right? It's part of a circle. So let's say the radius of the circle is R, this is R. So I also know the arc length will be the radius times the angle in radians. R theta, or R beta in this case, R beta is equal to the arc length. So I get R times beta. That's not too good. So I get R equal to E divided by beta, right? Here's our goal. We want to find this. I want to add all of these, so their sum is going to be one vector whose length is this much. That's the sum. So this vector here, which has length, so this vector is EP. Okay? And the question is, how long is that EP? How much is it? To figure that out, this is a chord, right? When I draw between these 2 points. The line perpendicular to the chord, from the center of the circle to the chord, it bisects the chord, right? The chord is divided by 2. And this angle here is how much?
1/2 beta.
Yeah, it's beta over 2. Okay, that's beta over 2. Now, how much is this then? What's this distance? EP over 2, good. Okay, let's look at the sine of beta over 2 is the opposite over hypotenuse. Okay, right. Sine of beta over 2 is equal to the opposite over hypotenuse. What's the opposite? EP over 2, good. What's the hypotenuse? R, excellent. So we're getting there. That means EP will equal to R sine theta times 2. So it would be twice R sine, I said theta, I mean beta over 2. One more. What is R? R is E over beta. R is E over beta. So we get EP will equal to twice. Instead of R, I will write E over beta times the sine of beta over 2, which then tells me EP is equal to E, and then sine of beta over 2 over beta over 2. The 2 here, if you bring it here, when you flip it, it goes upstairs. Okay. This over 2 can be a 2 on top. But I would like to write it like that. Okay, finally, what's the intensity? Intensity is proportional to what?
That square.
The electric field squared. Good. So remember, the intensity is proportional to the electric field squared, and then the intensity would be, and remember, intensity is 1/2 epsilon naught C E squared. And then there, so everything in front, I'm going to call it I naught, and then the sine beta over 2 over beta over 2, the whole thing squared. That's the intensity. And remember what beta over 2 is. It's what beta is. It's 2 pi over lambda A over sine theta, right? So let's substitute that here. So I get I naught, and then sine of, if you divide by 2, 2 pi becomes just pi. So you get pi A over lambda sine of theta, like this, divided by pi A over lambda sine of theta, the whole thing squared. Okay? Yeah, so that's the intensity. But I need to double check that I have it right. Pi A over lambda sine theta. Pi A over lambda sine theta. Sine of sine. Sine square. I know. Yeah, that looks good.
Is it supposed to be I equals I naught EP squared? So should there be an E?
And so the I naught contains that the EP squared. So I naught has the 1/2 epsilon naught C EP squared.
Oh, okay.
Yeah, it's already here. It's within this thing. I just called all that I naught.
Okay.
So that's the intensity. So now let's see if these intensities do make sense. Okay? And that'll be my probably last thing to do. So let's see if the intensities make sense. So first, let's make some observations. So here's the first observation. The intensity for dark spots, what should the intensity be if you have a dark spot? How much light do you have? Zero, yeah, the intensity should just be zero. When is the intensity equal to zero? The intensity would be zero if the sine of all this stuff is equal to zero, right? Yeah. And there is only one point that we have to be careful of, because if you have, you can't say sine of 0 over 0, because, or just go here. 0 over 0, that's indeterminate, and then we have to be careful about that one. I will get to that in a moment. But let's look at the other ones that are not 0, where this denominator is not 0, okay, where it's not 0. So we can have, when the argument of the sine is a multiple of pi, right? If it's pi or minus pi, 2 pi or minus 2 pi, 3 pi or minus 3 pi, that's when you get 0. So for dark spots, the intensity is equal to 0, which means this, sine of pi a over lambda times the sine of theta is equal to 0. And again, I'm going to treat the case where theta is equal to 0, that one we'll treat it alone. We're just going to worry about it's equal to 0, but this one is for, the inside is pi or 2 pi or 4 pi. So I need this. That means pi a over lambda sine theta must be an integer multiple of lambda. I'm sorry, an integer multiple of pi. And m is an integer, but it does not include 0. Okay? M is an integer that does not include 0. So cancel pi, and you get a sine theta is equal to m times lambda, and we had it somewhere. Yeah, right here. Location of dark spots, you get a sine theta is equal to m lambda, which is exactly what we had earlier, and we said lambda, m is plus or minus 1, plus or minus 2, and so on. Not 0, right? Not 0. Okay. Any questions on this one? Right? You have a question? No. Others? All right. Number 2, what if when theta is 0, meaning, right, pi is not 0, a is not 0, lambda is not 0, so the only thing that can make it 0 is theta. If you have sine of 0, you get 0. Sine of 0, you get 0. So when theta is equal to 0, we have the case of 0 over 0. 0 over 0. What is that? How much is sine of 0 over 0? It's indeterminate. Let me ask it this way. What is this? The limit as, let's say, as x goes to 0, sine x over x. You can do L'Hopital's rule? Yes.
1.
Yeah, it's 1 actually. It is 1. You can do L'Hopital's rule, or in calc you did it squeeze theorem. Yeah, anyways, it is 1. Yeah, it is 1. So this limit is simply 1. So what does it mean? So at 0, what do you get? The intensity will equal to what?
I know.
Just I naught. So it is the maximum. So the intensity in the middle, it is the maximum it can be. That's as big as it can be. That is the intensity. It's I naught. Right. So the intensity is equal to I naught. So in the middle, it is maximum as we expect. So that's good. Now, when do we find the intensities to be maximum? How about other maximums, other intensities? Well, as you move away from the middle, the intensity is simply going to decrease. Why? Because as you move away from the middle, you got this denominator here. that gets larger, right? As theta gets larger, the denominator gets larger. And so the intensity will decrease. Okay. And the intensities will actually decrease a lot. For example, let me see here. I had in my notes. Here they are. So here's the middle one, and then the one above it, and the one above it, and let's say the one above it. So here is 1, and 2, and 3, and 4, right? 1, 2, 3, 4. So this one here, the intensity here is I naught. The intensity here is a lot smaller. It's 0.047 to I naught. So you see, it decreased very quickly. The intensity here is 0.0165 I naught. Okay. And then the intensity here is even smaller. It's 0.0083 I naught. And you can solve this numerically. Because how do you find when the intensities are maximum? You can, right? You get this expression. It gets pretty ugly. You have to take derivative, set it equal to 0, and then find what beta should be. It gets messy. That's why they have it numerically. What we typically, you will see next week in the lab when we do it. You will see this, no problem. You will see this one also, no problem. And you will probably see this one also if the room is dark enough. This one, I don't think you can see it. So you will be able to see at least the first two, the middle one plus 2. Okay, so that is that. I had one more thing to say, and I forget what it was. Okay. Oh, yes, go ahead, please.
Go, I'll ask after.
Yeah. I was going to ask, you might be wondering, I said, this is 0 over 0 only at theta equal to 0, right? It seems like you can get 0 when theta is equal to pi, right? You get the sine of pi is 0, and the sine of pi is 0. And sine of 2 pi is 0, and sine of 2 pi is 0. But why don't we consider those? Why are those not even in there? Think about the physical picture. Yeah. What is theta? Theta is this angle. How large can theta be? If the screen is infinitely big, it can get to pi over 2. That's it. You can't get to pi. Yeah. So that's why it's the smallest is 0, but then the biggest it's pi over. It can approach pi over 2. Yeah. Was that what you were going to ask? No. Go ahead.
So you drew the intensities as little like half circle things?
That's supposed to be how big they are. So this one, I should have drawn this one like this big. That's how big the intensity is compared to this one. It's just how high. Like this is 1 times, and so this one should be like what? I don't know how many times that is. Like 20, 30 times, 50 times. Yeah. Does that make sense? Yeah. Anybody else? I do have a couple of examples I wanted to do. This one. Only problem is they take longer than the minutes I have. Let me, in that case, let me ask you the following question, if you don't have a question for me. Yeah? I have a question for you. Let's say you take the double slit experiment, and then you do it underwater. How would the pattern change? What would change if you want to find, I say, find the maximums. Find the condition for the maximums, right? For when it was in air, it was d sine theta equals to m lambda. What if you put it under what? Let's say the index of refraction, let's just call it n. Okay. Think about what you would do in that case. Let me erase here. What would change?
Will you divide it by n?
Yeah. That's basically it. Yeah. So if you're doing it underwater, this is the double slit, right? This is still d, and this is d sine theta, that's the path difference. But we have d sine theta is equal to m times lambda, but what's lambda now? You're underwater. So it's lambda over n. Becomes lambda over n. If you like, you can just multiply both sides by n. If you multiply both sides by n, it would be n times d sine theta is equal to m times lambda. And that makes sense, right? Remember what we said? You amplify the length by a distance, by a factor of n. The length, it's as if it traveled even more by this. Okay, good. I think we did a good amount of intensity problems today. I'm sorry, not intensity, double slit.